Hello everyone, my name is Ting Tat Yang and my title today will be on bioacoustics. So bioacoustics is a cross-disciplinary science that combines biology and acoustics. It focuses on how living organisms like animals produce, transmit and receive sound. This includes the anatomy and neuropsychology of sound production and hearing and how acoustic signals travel through air, water or solid media. In practice, bioacoustics usually involves three steps. First, the animal will produce the sound. For example, a bird will sing a song, and then the song will then propagate through the air. Essentially, the researcher will capture these songs using detectors. With passive acoustic monitoring, these researchers can actually leave the recorders on the field for weeks or months to continuously listen without disturbing the wildlife activity. The recordings are then going to be analyzed using softwares that visualizes spectrograms and extract patterns from large data sets that have already been pre-established. Bioacoustics has become a very powerful tool in ecology and conservation. It is widely used to monitor birds, bats, or even marine mammal populations over large areas and long time periods. Because many species are actually easier to hear than to see, especially the nocturnal ones, like bats, acoustic monitoring often outperforms traditional visual surveys. Recordings oftentimes can reveal which species are present and how they use habitats and how the communities change over time in response to disturbance or climate change. These data actually supports the management plans and conservation strategies employed by respective governments. Bioacoustics monitoring has been revolutionized by modern technology. Let me show you what has changed. So before the 2010s, researchers would actually go into the field with tape recorders or early digital recorders. They'll collect data over a few weeks or even months, and then they'll spend some more time listening to and then analyzing the recordings in the lab. Coverage was limited because it was tiring, and physically researchers cannot go everywhere. And this essentially led to very high costs and poor research data. Today, however, everything has transformed. Autonomous recording units, ARUs, can be deployed across vast landscapes and left running continuously for months. These are often solar-powered and wireless, sending data back to researchers in real time. This means researchers can actually monitor areas we could never visit regularly, for example, like rainforests or even ocean or even mountain peaks. Artificial intelligence has dramatically accelerated this analysis. Machine learning models can now classify thousands of hours of audio in seconds, identifying species and counting call events with accuracy rivaling that of human experts. This has made large-scale monitoring feasible, and global networks are emerging. So some real-world examples of how bioacoustics is making a difference is actually deploy hydrophone arrays across oceans to monitor whale migrations and population recovery. Essentially, these recordings reveal the population trends and also the changes in whale behavior in response to shipping noise and climate change. Second example is bats. Essentially, bats produce these ultrasonic waves, which these detectors will pick up in the forest, and then they'll track the bat activities and species diversity. For example, during the COVID-19 pandemic, acoustic data helped researchers study how lockdowns affected nocturnal insect activity, which in turn affects bat prey availability. The third example would be amphibians. Essentially, autonomous recording units placed throughout tropical forests continuously capture frog calls. These calls actually have revealed new species. They tracked declines due to disease or habitat loss and helped prioritize conservation areas. In each case, passive acoustic monitoring actually allows the scientists to gather data across vast areas and long time periods, and this would reveal patterns, again, that would be impossible to tag with traditional field surveys. So to conclude, bioacoustics actually help us listen in on the living world. By recording and analyzing these animal sounds, we actually gain insights and valuable information into the species behavior, their community structure, and the ecosystem health in a non-invasive and cost-effective way. This is becoming essential for monitoring biodiversity during a global extinction crisis or even to design better conservation strategies. With continuous advances in sensors, passive acoustic monitoring, and AI-based analysis, these bioacoustics will only become more and more advanced and become more and more central to ecology, conservation, and our understanding to biodiversity in general.